The next problem is still from the Cambridge Mechanics book. This will be about the triangle of forces for three-force equilibrium problems. Let's have the first problem. Okay, the problem says an object is in equilibrium by the action of forces of 10 Newton, 8 Newton, and 9 Newton as shown in the diagram. Find the values of theta and p. Okay, so the problem is asking us to find the two angles. So in the diagram, you can see that the given are only the forces. We have 8 Newton, 9 Newton, and 10 Newton. And the unknown or the problem is to find the theta and the p. Now, so when we will be doing the method of the triangle of forces, what we're going to do is that we need first to redraw the diagram as a triangle of forces. Okay, so we're going to redraw it. So it will become so this is your 8 Newton. Next, this will be your 9 Newton. And the last, we're going to check the direction. That will be your 10 Newton going upwards. Newton. This is the 10 Newton. Okay, so observe that in your triangle of forces, what we're doing here is that we are just we rearrange or withdraw the given forces in terms of their own direction, just like this one. The 8 Newton is going southeast. Look at the direction and the triangle. It's still southeast. Next, your 10 Newton is going to the north, so that's why it's going to the north. Your 9 Newton is going southwest, so that's why here it's still the same. So what we did is we just combined the three forces so that we will be able to form a triangle. So with this, we can make use of the triangle of forces. So in the triangle of forces, we can either use the sine law or the cosine law. It depends on the given problem. So here in the given, let's try to plot the points. Let's try to edit this. Okay, let's try to plot. Now the thing is, we're going to extend the one with the arrow. Okay, we can extend it. Okay, we can extend that going that way. And then we can also extend this one going that way, and this one actually is going here, but I think there is no, let's try to check if there are some angles there. Now, based on the problem, the opposite of 8 Newton is the P. Okay, the opposite of 8 Newton is the P. So that's why we're going to write the P this way, in here. So this will be your P here. Okay, that's the opposite of 8 Newton. Next, In the problem, the opposite of 9 Newton is the pi. So that's why we're going to write the pi here, opposite. So pi will be here. Okay, the opposite. So if there is another angle here, 10 Newton, so we're going to put it approximately here. But problem. So that's the only two. So opposite of 9 Newton, based on the problem, is the pi. Sorry, it's the theta. Opposite of 9 Newton is the theta. And the opposite of the 8 Newton is the p. Okay, now let's try to start. So in this problem, since there is no given angle on the opposite of them, the two angles are unknown, so we cannot use the sine law. So what we will do here is that we will be using, or we will utilize, the cosine law. Now, in what we have learned in trigonometry, cosine law, okay, cosine law, okay, we can have one side. So we will have c squared equals a squared plus b squared. So if the one that you are solving is the c, so that will be c squared equals a squared plus b squared minus 2ab. So the angle that you're going to get is also the one that is in the c. So approximately it's cosine c. So mean to say the angle that is opposite the c. But however, here, since we don't know any angles, and we are considering here 3/4 equilibrium problems, so we can just, instead of writing the angle there, we can just represent it as 180 minus the let's say the theta or the p. So let's just use the theta, so in general, so based on this one. But later, if we will be solving for the p or alpha or whatever, so we can just change it. So with this, we can transform this formula so that we will be able to solve for the angle. So if we're going to transform this, we will have cosine 180 minus, let's say, theta is equal to a squared plus b squared minus the c squared all over 2ab. So in this problem, we will be making use of this formula. Okay, we'll use that one. Okay, now let's proceed. So let's start the first one. Let's start to solve the theta. Okay, so as you can see in the problem, the theta is between 10 Newton and 8 Newton. Theta is between 10 Newton and 8 Newton. So if we will apply the formula that we had, that will be equal to cosine 180 minus the theta will be equal to 8 squared plus 10 squared minus the side that is opposite the angle, which is 9 squared. So you put first the one that is in between the side of the angle. Okay, that's why we have 8 squared, 10 squared, and then subtract the side that is opposite the given angle. So all over, so 2ab. So that will be 2 times the 8 times the 10. Okay, 2 times 8 times 10. Okay, let's continue. So using the calculator, we're going to compute this. We're going to arrive with Okay, so our theta here will be equal to, theta is approximately 121.2 degrees. Okay, the theta is equal to 121.2 degrees. Okay, so solving this, so we're going to solve the value of this one first, and then when we're going to have our cos, the value of that, and then subtract by 180. Okay, or solve for the theta. So the theta here is 121.2 degrees. Now, the same process on solving for your p, excuse me, in solving for your p, so the same process. Let's put a boundary here. So that will be cosine 180 minus the p. So look at the location of your p. The p is here. It's between 10 Newton and 9 Newton. Okay, so this is the opposite side. So because of that, we're going to have 9 squared plus 10 squared minus the opposite side, which is 8 squared, all over 2 times 9 times 10. Okay, so let's use the calculator to solve. So the same thing, so what we're going to do is compute for this. After that, we're going to get the our cos of the result, and then solve for the unknown angle. So using your calculator, we can say that the P here will be equal to 130.5 degrees, one decimal place if it's angle. Okay, 130.5 degrees. So this is using the triangle of forces. However, we made use of the cosine law because all the unknowns are the angles.